So hello everyone, the next chapter that we're going to do is D and F block. That is the first chapter of inorganic chemistry in class 12th. Again, this is a very interesting chapter. So first topic that we're going to study is what is transition element? What are these transition element? Okay. So basically, let us see the periodic table. The periodic table is divided into the different blocks, that is the S block, P block, D block, and F block. In this chapter, we're going to study the chemistry of D block and F block. Now you must be thinking, okay, D block elements are also known as transition elements. Why? Because they bring about a transition between S and P, isn't it? They are between S and P, so there is like a transition. But not all D block elements are transition elements. Let us understand. Transition elements, they are elements which have incomplete D subshell, either in their neutral atoms, okay, or in their ions. They should have incomplete D subshell. So what do I mean by D subshell? So for this chapter, you have to know how to write the electronic configuration. So first you need to learn that from class 11th, chapter 2, structure of atoms. So then only you can write, you can solve this chapter. Okay. So for example, let me consider the electronic configuration of, let's say, chromium. Okay. So chromium, the atomic number is 24. So if I would see the electronic configuration, that is, 4s1 3d5. So if I would see D subshell, so this is how I draw the D orbital. 1, 2, 3, 4, 5. So I have 5 electrons and all electrons are unpaired, right? So D orbital is incomplete. D orbital can hold a maximum of 10 electrons, and you can see here D orbital is incomplete, right? So if it is incomplete, that means yes, it is a transition element, okay? So transition elements or transition metals are the metals that have incomplete D subshell, either in the neutral state or the excited state. Now, let us consider for zinc, okay? Zinc, the atomic number is 30. So zinc atomic number 30. So the electronic configuration is 4s2 3d10. Now you can see zinc, the D subshell is completely filled. So what do you think? Is it a transition element or is it not? Yes, you're right. It is not a transition element because D subshell is completely filled. And for it to be a transition element, it has to be empty D subshell, right? Like at least one place have to be empty. Like, it has to be incomplete. So if it would have been 3d9, it would have been a transition element. Now, the definition says that either in ground state or in the form of ion. We know that zinc shows the oxidation state of +2. So the configuration of zinc becomes 3d10. So it is 3d10. After leaving 2 electrons, it is 4s2 3d10. So after losing 2 electrons, it becomes 3d10, right? Because Zn2 plus means we are removing 2 electrons, like we are releasing 2 electrons, so it becomes 3d10. Now still, even after losing 2 electrons, the configuration is 3d10. That means fully filled D subshell. What does it mean? This means that zinc is not a transition element, right? That means all the D block elements are not necessarily transition elements, right? Okay, let's take another example, copper. The atomic number is 29. So the configuration is 4s1 3d10. Okay, now let me consider copper in +1 oxidation state. It is +1, I'll remove 4s1, 1 electron, so it becomes 3d10. Still, it is not a transition element because it has 10 electrons, fully filled D subshell. Copper 2 plus, I remove 1 more electron, so it becomes 3d9. Yes, now we can say that copper 2 plus, so there is, the D subshell is incomplete. Hence, copper is a transition element, right? So what is the definition? The definition says that transition elements are elements which has, unpaired electron. It should have unpaired electron or empty D subshell, either in its ground state or the excited state. So this is the ground state. Ground state, it has full D subshell. But in the excited state, that is in the form of copper 2 plus, it has incomplete D subshell. Hence, copper is a transition element, right? So this is it about transition elements. I hope you understood it. For this, you need to know how to write the electronic configuration. Okay, let us move to the next topic, that is lanthanoids. So lanthanoids are present in the F block, right? So if you would see in the F block, you can see lanthanum here. That is the atomic number is 57. And if you would see hafnium here, the atomic number is 72. How did this happen, 57 and then 72? Because in between lanthanum and hafnium, we have the F block starting, right? So F block actually starts from cerium. Lanthanum is a D block element, but we place it with F block because the property of lanthanum is actually similar to the property of the first series in the F block. And hence that is why the first series is known as lanthanoids, right? The first series we call it lanthanoids, right? Because it is starting with lanthanum, right? So actually the F block elements, they basically the lanthanoid series start from cerium atomic number 58 to lutetium 71. Now, if you would count from cerium to lutetium, there are 14 elements, right? So in between lanthanum to hafnium, there are 14 elements, and these 14 elements are called lanthanoids, right? Which are in F block. Similarly, we have AC. So actinium and rutherfordium. In between starts the actinoid series. But today we are going to talk about the lanthanoid series only. So lanthanoid series are present in the F block. They start from cerium and they end at lutetium. There are 14 elements in the lanthanoid series. Okay, let us move forward. I hope you can now recognize where the lanthanoid series are present, right? Okay, so let us see. In lanthanoid series, these are lanthanoids. Okay, so basically, if you would write their electronic configuration, you can see the electron is entering into the 4f subshell, right? So the general configuration of lanthanoids is 4f1 to 14, 5d0 to 1, and 6s2, right? Okay, so like for example here for PR U59, we can write it as 4f3, 5d0, and 6s2. This is the general configuration. Okay, and to write this configuration, you need to remember this. This is Aufbau's principle, that how electrons are in the increasing energy of the subshells. Now, what are the exceptions? These are exceptions in the electronic configuration: lanthanum, cerium, gadolinium, and lutetium. Now, whenever the electron enters into the D subshell, that is an exception. So we will study this in detail, why it is an exception. So I have highlighted the exceptional electronic configurations. Now, these are important because they are asked in the exam, right? So you need to study them. That is lanthanum. Okay, lanthanum, cerium, gadolinium, and lutetium. But lanthanum is not an F block element. It is actually a D block. Can you see there is no 4F present in lanthanum? There is only 5D, but its properties are similar, so we put it here. Okay. So what are the physical characteristics of lanthanoids? So lanthanoids are silvery white soft metals, right? Okay. And they tarnish rapidly in the presence of air. Okay. So all the lanthanoids are silvery white soft metal. Tarnish means like, how you must have seen silver. So silver after some time it tarnishes rapidly, it becomes black. Okay. So its hardness also increased with the increasing in atomic number, and all the lanthanoids are very good conductor of heat and electricity. So you can see here, lanthanoids, they conduct electrons very well. So they are very good conductor of heat and electricity. Okay, so thank you so much for paying attention. I hope you really enjoyed D and F block elements. But as I said, if you don't know how to write the electronic configuration, if you don't know Aufbau's principle, Hund's rule, so you won't be able to understand this chapter. So to understand this chapter, you need to know how to write the electronic configuration very well, and you need to know the Aufbau's principle and the Hund's rule, right? So if you want to study it in detail, we can connect through Urban Pro and go over the basics. But I hope whatever I told today, you all understood that. Thank you so much for your time and patience.